Hello world. I'm Evan Gudmstead, an instructor of application and web development at Rankin Technical College. It is summertime, and with summertime I'm teaching an online class of C#, and I'm introducing .NET MAUI to my C# class. And so as part of that introduction for my class, I am taking different tutorials in .NET MAUI, and I'm sprinkling them in, and for my class's benefit. And so I'm just going to do a tutorial. When I do these online tutorials, I sometimes stream them, and people hop in and chat and have small conversation, and maybe they learn a thing or two, maybe they don't. But nonetheless, I just kind of stream these tutorials as my learning journey goes with .NET MAUI. So this tutorial was on Microsoft's .net.microsoft.com/learn, and then you kind of go to the mobile and desktop. That's what you build with MAUI apps. And then learning courses brought me here, and I'm just going through, did the first one, and now this is this one here, create a UI in .NET MAUI. So this is the tutorial, estimates 54 minutes with some learning objectives. I'm sure I got the stream up and going. That's cool. So create a user interface by using XAML. So I've definitely done a fair amount of this already with .NET MAUI. If you're going to do anything in .NET MAUI, you're going to be creating a UI with XAML, but I'm sure there's plenty to learn. As I've only been doing this for a month or so now. Learning objectives, benefits of using XAML over defining the UI. The benefits of using XAML over defining the UI. So I think I have an idea of what's going to go happen there. The types available for defining .NET MAUI using XAML, and the properties. So like the entry type and the image type, I think, is where we're going there. But we shall see. How to handle events, wire them up, wire up events. And with my experience, you just can literally code an event handler or event listener and on click and just name that. But maybe there's more to it. How to create and use XAML markup extensions, how to set platform specific values. All right, so we got Visual Studio 2022 with the .NET MAUI workload installed. So we got the prerequisites, we got familiarity with C# and .NET, and let's go. Whether I read this out loud or not, I don't think makes a difference. .NET MAUI lets you create an app's UI dynamically by C# code. However, sometimes it's more appropriate for a static UI. XAML provides a way to lay out the UI at compile time. The XAML description of the UI also provides a degree of documentation, allowing you to quickly grasp the way in which the UI is presented to a user without having to delve into the application code. Okay, so scenario: you work for a power utility company as a mobile developer. You're responsible for improving the company mobile app that engineers use. Currently, the app's UI is built using C#. However, you notice it's becoming more difficult to manage the UI. Due to the app getting more complex, it's becoming increasingly hard to understand the core logic because it's mixed with UI code. You want to find a solution that will introduce clean separation of UI and behavior. Separating UI and behavior allows you to design your design expert to focus on what they do best, and then you'll have time to focus on the behavior. You define the UI in .NET MAUI with XAML. XAML gives you a clean separation of UI and behavior. XAML also makes it easier for design expert and design tools. You'll learn how to create a .NET MAUI app that defines its pages and controls using XAML instead of C# code. Creating the UI on XAML allows you to separate your concerns. It's always the answer, right? Separation of concerns. I already covered these objectives. Benefits of XAML. XAML is a markup language. Instead of C#, using XAML, you can split up your UI and behavior. You'll compare using XAML with the defining UI layout using C#. You'll also learn about some of the benefits of using XAML as a markup language. A markup language is a language that you use to introduce elements in a document. You describe elements using predefined tags. The tags have meaning in the context of the domain where the document is used. In HTML, we know what HTML looks like. You don't need to understand all the tags. What's important to see is that it says hello world in its content. You've already created a web page with HTML or XML. So yes, I've worked with both, of course. It is common for the files to contain markup language to be processed and interpreted by other software tools. The interpretive nature of markup is exactly how XAML is intended to work. What is XAML? I believe they said it was an extension of XML. XAML is a declarative markup language created by Microsoft. It's good to know who created it. And I'm pretty sure it's used in mostly Microsoft Docs, although not exclusively in Microsoft software. XAML was designed to simplify the process of creating the UI. XAML documents you create contain elements that declaratively describe the UI. Keep in mind that these elements in XAML directly represent the instantiation of objects. Once you've defined an element, you can access it in code behind files using C# code. So what's the difference between .NET MAUI XAML and Microsoft XAML? XAML is based on Microsoft 2009 XAML spec. However, that spec defines only the syntax. As with WPF, UWP, and WinUI3, all of which use XAML, these elements, the elements you declare in the XAML will change. So this WinUI3, I believe, is what MAUI uses, and these are older technologies. XAML first appeared in 2006 with WPF. If you've been working with Microsoft XAML for a while, XAML syntax should look familiar. There are some key differences between .NET MAUI XAML and XAML used by other UI tools. The structure and concepts are similar, but some of the names and classes, names of the classes and properties are different. The best way to see XAML in action is to look at C# coded content page. You can then compare it to another page that has the same UI using XAML. So here, yeah, everything's in C#. Background colors, layouts, login buttons, adding these buttons to the layout. So make a background color, make a layout, make a control, add the control to the layout, set the layout in the content property of main page, wire up an event listener. There you go. This just reminds me, this reminds me of my first language where I built in an object-oriented language and actually built a UI was Java. So I mean, C# based on Java. So this is like very similar to building a UI in Java. Instead, here we got the same thing in XAML. I mean, I don't think anyone would debate that this XAML is going to be easier, right? But static versus dynamic. The benefit of this is that this can be more dynamic UI versus this is more static. So trade-offs. The C# code that initializes the page and implements the handler looks like this. So here, login button clicked, wires up to this login button clicked with a sender and event args. Initialize component method. Right here. And the constructor reads the XAML description, loads the page controls, and sets their properties. So yeah, that's important. You only call this method if you define a page using XAML. The previous example does not invoke initialize component. So this main page does not have initialize component. Once again, the structure allows for separation of design and behavior. The declaration, the UI declaration, is contained in a single dedicated source file, which is separate from the UI behavior. Additionally, the XAML markup provides clarity for developer trying to understand the look and feel. Benefits of XAML: allows you to separate the concerns. The separation helps you build each piece independently, and makes the entire app easier to manage. They really drive that point home. Which method? Well, I only mentioned one method. Types and properties in XAML. XAML is a declarative markup language. It is designed with the idea to simplify the process of creating your UI. The elements in XAML directly represent the instantiation of objects that you can access in your code behind files. In this unit, you will learn how to use the types available in XAML and how to set and read your properties of this type. I'm hoping I can start coding soon, but I don't know, it might just be a reading tutorial. Where are the types? In .NET MAUI implements a XAML parser that parses your declared XAML elements and instantiates each element as a .NET type. XAML parser. The XAML dialect that .NET MAUI parser understands is specific to .NET MAUI, although it's similar to XAML and other frameworks. So this is XAML that's, again, just good in .NET MAUI. It's similar but different to other frameworks. The .NET types that implement the items, XAML code, blah, blah, blah. Okay. The .NET types that implement the items, XAML code, identifies are implemented by code in several assemblies. Many of these assemblies are included as part of the templates. You can also utilize other types by loading the appropriate assemblies as part of your project. Many assemblies are available as NuGet packages. Most of the common types are found here and here. Each type is defined in a namespace. In your XAML code, you specify the namespace for the types you reference. Most MAUI controls are here, while Microsoft MAUI controls, while the Microsoft MAUI defines a utility, and the graphics namespace includes generalized types such as color. The option to introduce types this way highlights the extensibility of XAML. XAML allows you to create your app's UI with freedom to include XAML elements, .NET types, and custom types. For the most part, you don't need to worry about these namespaces because they're brought in automatically with the using features and adds them application-wide. Okay, so these types are in these namespaces, and you don't have to worry about it because it's going to be brought in automatically. How to instantiate types. The first step to building a UI is instantiating the UI control types in XAML. You create an object by using object element syntax. It is a standard, well-formed XML syntax to declare an element. You want to label it, looks like this. Self-closing tag. Remember that the XAML parser, to successfully parse a XAML definition, it must have access to the code that implements the control and defines its properties. The controls available to the .NET page are implemented as a collection of assemblies that are installed in the NuGet package. The controls are located in the .NET namespace. In C# code, you bring a namespace into scope with using directive. In a XAML page, you reference the namespace at the top of the page. So all these controls are kind of defined in here in this namespace. Instead of a using statement like you do in C#, you got the XML namespace. The following code shows the namespaces that XAML page created. Yeah, a lot of times this makes sense though, it's good to know. I mean, this content page was always the shell, but knowing that these controls are pretty well defined in here. And that's how XML works too. You always kind of have your schema for your XML document in the parent node. The first namespace is the page's default. The URI form of the namespace is typical XML and looks somewhat different from those which you might be familiar with in C#. However, the URI is simply an alias for one or more namespaces defined in the assemblies in the .NET MAUI NuGet package. So specifying this namespace at the start of the page brings all the MAUI types and controls into scope. If you omit this namespace, you won't be able to use buttons, labels, entries, or layouts. And the second one references the assemblies that contain the various .NET intrinsic types like strings, numbers, and properties. In the preceding XAML code, the namespace is assigned with the alias X. In the XAML code, you reference the types, preference. In the XAML code for this page, you reference the types in this namespace by prefixing them with X. For example, each XAML page is compiled into a class, and you specify the name of the class that's generated with the X class. So here you define the alias, and here you use and say, hey, this alias is class attribute. reference types in your own assemblies in the XAML code through a XAML namespace. For example, if you have types and methods that you want to use in your XAML code in a namespace named utils, so this is the alias, my code, and this is the namespace, utils. I did this in another tutorial where we were doing MVVM view models. You'll see more of this technique later on. Okay. These are the properties. Text property, text color, pretty clear cut. In C#, looks like such. One thing you might notice is that it's different in the XAML code than C#. Is the property values. Color.black versus the string black. This is because the string is only a valid element that you can use for XML attribute values. It's always going to be strings on the right hand side of that. Therefore, there needs to be a way to convert each string into the correct type. In XAML, you do this conversion by using a type converter. What is a type converter? A type converter converts the XML attribute specified as a string to its correct type. To understand the concept better, let's look at this. A label, text color, font size, font attributes. The text is a string, which means XAML doesn't need a type converter. Text color is a color, so XAML requires a type converter to translate the string into the corresponding color value. So yes, black needs to be converted to color.black. The font size is an int, so XAML requires a type converter to parse the string to an int. Finally, font attributes is an example of a complex object. You can combine the values in a comma delimited string, bold and italic. The comma delimited string is treated as flags based enumeration on the appropriate type converter that will apply bitwise OR to the property. .NET MAUI has converters for most of the built-in classes and uses these converters automatically. However, if a converter doesn't exist, you can write your own. Seems like something I don't want to do today. Type converters are great for simple property strings. However, in some cases, you need to create a full object with its own property values. The solution to this problem is changing the property assignment to used element-based syntax. I'm looking at my streaming statistics. This syntax is called the property element form. Again, I'm hoping I'm going to start coding soon, but we're getting there. The syntax involves breaking the property setter into a parent-child form, where the property is expressed in an element tag of the type property name. Suppose you want to assign a gesture recognizer to a label so that the app can tap on the label. The app user can tap on the label. The gesture recognizer is a complex object with its own properties. Typically, these properties need to be assigned to ensure proper functionality. I've seen a little bit of this. gesture recognizers. Default content property. Some .NET MAUI controls have a default content property. The content property allows you to specify the value of a property on a control without explicitly stating it in XAML. Take a look at the following XAML fragment. We got a vertical stack layout, adds a label as a child. Because it's common to add children to a layout, its children property is the default content property. This means you can add a child without explicitly specifying the children as follows. What does a type converter do? The XML attribute value specified as a string to the correct type. How do you bring your own custom types into the XAML? X:class. XML namespace my code. This. Event handling in XAML. After you created your XAML, you can add code to respond to the interactions that occur as a user visits the page. .NET MAUI notifies the application of user input and interactions through a standard .NET event. In this unit, you'll learn how to handle these events and carry out the expected operations. Event handling needs to refer to the specific controls and their properties. You can assign a unique name to each control. X:"name does two things. It adds a private field to the code behind that is mapped to this element. Use this element in your code to interact with the visual element to set runtime properties and to handle events. It makes the element known to the XAML through this name. You can't use any arbitrary string when you name the element. The value assigned to XName attribute is used to create a field in code. Instead, you must conform the naming conventions for a variable. It must be unique because it's compiled into the code behind. After you provide a name, you can interact with that element in the code behind. The following XAML is a label called counter label. The field won't be initialized until the initialize component method of the page is run. This method is part of the XAML parsing and object instantiation process. Place any code that interacts with an element that's defined on XAML after this call. The exception to the rule is the content page class itself. You can access all properties on the class prior to initialize component method. However, if you set any properties on this class in the XAML, these property values will override any values you might have set before. Use an attribute to wire up events. Many controls expose properties that correspond to the events in which those controls can respond, such as clicked for a button. Different controls support different events. A button you can have clicked, pressed, and released, while an entry control has text changed. You can initialize event property in a page XAML markup and then specify the name of the method to run when the event is triggered. The event must meet the following signature. It can't return a value, it must be void. 2 parameters, object and event args. It should be private. This isn't enforced, but you make an event handler public, it becomes accessible to the outside world. And event handlers can be async if it needs to run asynchronous code. This is an on counter clicked event handler. The on followed by the name of the control. And the name of the event. On, the name of the control, the name of the event. I like that convention. Again, you're manually coding this in the code behind. Like on Windows forms, you have ways to generate these, wire up these event listeners, but it's more automated over here. Just literally just, well, I don't know if it's more automated, but you just got to code it yourself. Wiring up events in XAML is convenient, but it mixes the control behavior with the UI definition. Many developers prefer to keep those elements distinct and do all the event handler subscriptions in the code behind 2 named elements. It's easier to see what's hooked up and where behavior is mapped. This method also makes it harder to accidentally break the code by removing a handler in the XAML without realizing it. The compiler won't catch a removed handler. It will become an issue if the code doesn't perform properly. So here is where you tell your button clicked to run this event listener. Whether you choose to wire up event handlers using XAML or by using code, it is a matter of personal choice. To wire up an event handler in code, use the += operator to subscribe to the event. You typically perform this operation in the constructor. You can remove it. What are the parameters? The name of the event and the name of the control. A reference to the XAML page, a reference to the control to raise the event and the event args. Which operator can use to wire up an event handler in C#. Create your first XAML page. 5 of 9. And 33 minutes in, we'll see if we keep it to an hour. Exercise, create your first XAML. Engineers from your utility company regularly make customer visits to repair appliances and perform other maintenance tasks. Part of the app allows the engineer to make notes. You've been asked to add some further features to the page. Before you start, you want to understand how the page was created. So you look at the source code, you notice the UI was created by using C# code. Although this approach works, it intermingles the code that handles the layout with the code that controls in which the UI works. You realize before long there's a danger of the 2 aspects of the app becoming locked together, making future maintenance difficult and possibly making the app more fragile. As new features are added, you decide to separate the UI from the logic, UI logic, by extracting the C# code. This module uses .NET 9. Ensure you have .NET 9 installed. And by running this in your preferred terminal. Of course, I have .NET 9 installed. clone this repository. Oh, don't take me there. Move to the exercise 1 folder. Open the notes solution. Expand the notes project. Expand the main page XAML and open the main page XAML C#. Main page XAML, main page. Let's get you over here. Empty. And here is our app. This has been a learning experience for me to really just have a powerful computer. All these MAUI apps, they take a while to load, and Visual Studio takes a while to catch up and recognize everything. The constructor has all this code in it. The UI has a vertical stack layout with a label and editor and a grid with 3 columns. So vertical layout, label up top, then an editor, then your grid with 3 columns. Note that the main page class also contains event handling methods for the buttons and some code that initializes the editor. This code isn't distinguished from the UI definition. So here's our event listener wiring it up. Build and run the app on Windows just to see what it looks like. Select F5 to build and run the app. I gotta figure out why. I gotta run it twice. All right. So here's the Notes app. So we see it running. We know what it looks like. Vertical layout, grid, couple controls, couple buttons, couple events. Simple enough. Okay, the class is Notes main page. If I kind of back up here. All good there. Add a vertical layout with some margin. Add a label. Add an editor. Height request of 100. Enter your note. Add a grid to the vertical. The grid should have 3 columns. Column definition 0, 30 and auto. 3 columns. The first and third are automatically sized. The second has a width of 30. Okay, here's our first button that goes in the first column, column 0. Another button. It's 3 columns, but we're using column 0 and column 2. There's some space in between. Remove the layout code from the code behind. Expand the main page XAML node. Remove the editor field from the main page class. Of course, if we do that, and we do that, so the editor's gone. In the main page CS, in the main page constructor, remove all the code that creates a user interface element and replace them with a call to initialize component. Add the code that checks whether the file is used to store if the notes exist, and if so, read the content and populate the editor text field. It should look like this. The constructor should look like this. Public main page. So here's our constructor. So if the file name exists, then set the text from reading from that file. Little file IO, that's cool. Rebuild solution. And the event listeners are already here. Build, rebuild solution. Just a reason for more RAM. Let's see how much RAM my computer has. I'm pretty sure I've got my computer. $32 gig of RAM. Okay, build succeeded. Let's run it. I wonder if it's only me that has to run this 3 or 4 times. It's been so bad sometimes I have to reboot Visual Studio. For no good reason. It'll run eventually. Alright, let's close it down. Interesting. Makes me feel like it's something that I did, but I've done it enough now where I see most of the time it's not. Build is active. Patience. Well, if anything, I'm going to tell Microsoft that their estimated time on these tutorials, if you're reading it, like I'm trying to be thorough and read it, I mean, I'm pretty fast on the computer, but it's longer than an hour. Build, rebuild. This is just hanging on me. Let's terminate it in the task manager. $32 gigs of RAM. The thing should load fast. Makes me want 64 gig. Okay, rebuild solution. Whoa, 5 viewers, it's a rush. Hey everybody. I'm just following a Microsoft tutorial, learning a little bit about XAML. And just following this Microsoft tutorial and learning. Hope you guys are having a good Tuesday out there on the internets. Thank you for the kind words, Alex. Yeah, I enjoy it. I've been in this space for a while. I enjoy learning, and as soon as I learn something, I repackage it as what I've learned and share it with whoever's willing to listen. And sometimes those are students of mine, and sometimes people on the internet. So the problem that I'm having frequently here is I click to start with debugging, and sometimes it boots up the app and sometimes it doesn't. Let me try a different emulator. Let me try my Android emulator, see if this is going to make any difference. Okay, this Android emulator, this is like the last app that I was building. So that should close down and open. It's nice to have kind words from internet strangers. Okay. My emulator. There we go. So I found my emulator. My emulator is awake. See if it deploys this app. Sometimes, again, patience is a virtue. I'm just waiting on this thing to deploy. 64 gigs of RAM recommended. Hey, there she goes. So I'm just .NET MAUI. Hardware requirements. That's not enough. Yeah, I'm just going to make my own requirements on this one. Hey, there's my app. So, on save button clicked. So the delete button worked. It doesn't really give much of a notification when it saves that file. Okay, nonetheless, we are able to move on now. Much of your XAML definition will be settled at compile time. You often know where elements should be positioned, what colors and fonts, and what literal values should be assigned to properties. However, sometimes you need to set a property that can't be determined at compile time. These values are only known when the program is running. In these situations, you can create an object that provides a value to XAML at runtime. Markup extensions for this purpose. Markup extensions. In this unit, you'll learn how to create and use markup extensions. Markup extension is a class that you use in a XAML to access runtime values. Suppose you have many labels in your UI and you want to set the font size to the same value throughout the app to ensure all the labels styling is consistent. You can repeat the same setting for every label, but what if you want to change it? You need to find every instance of the property and make the change. Also, suppose you don't know what value to use. It could be calculated based on factors like device orientation, resolution, other considerations. In these cases, you need something more sophisticated than a hard-coded literal. This is where the markup extension is useful. Markup is going to give you flexibility on how you obtain a value that gets used in XAML. A markup extension is a class that implements markup extension. And then there's an interface with a method called provided value. This method's purpose is to supply a value to your XAML markup. I mean, this tutorial seems a little silly sometimes. It just goes from like basic labels and layouts, and now here's markup extensions, which I don't know that you would end up using a ton of this. I don't know how how common these are. So like, yeah, we can learn how to do this, but like the scenario where they're useful is that a common scenario? My gut tells me no. But that's okay. So we code a class. The class has an interface. We implement the interface. The whole purpose of this method is to provide a value to your XAML. Notice the return type is an object. So the value can be any type as long as it's appropriate. So long as it's appropriate to the place in which it's being used. For example, in a markup extension that calculates a font size, it should return a double, right? So that makes sense. The service provider parameter contains contextual information about where the markup extension is being used in your XAML code. Among other pieces of information, it identifies the control to which the extension is being applied. You can keep the markup extension for the font size property simple. In the following example, the main page class exposes a double to a field named myFontSize. So here's our class with the interface. It returns a double. My page, my font size, 28. Must be static. The my font size field must be static of the main page. This doesn't look static. A const value is static. Oh. I don't think I've heard that before. In many languages, const variables are by default considered static. That means they are not mutable. I know they're not mutable. And there's only one copy of the variable across all the instances of a class. That's what static means. I just didn't realize that. I'm almost embarrassed. I didn't know that. It might be the most useful thing I've learned today. Did you guys know that? Constant variables in C# are by default static. I got 4 concurrent viewers. You guys know that? Huh. It says this is static because it's constant. Applying the markup extension to a control in the XAML. Font size is my code. Here's where you define my code. And here's the class my MAUI app. That's the namespace that brings in main page. My code, global font size, which was defined right here. So there's a convention here, global font size extension, and you put the global font size here. a static extension class. As useful as the global font size markup extension is, it is unlikely that you'd create such an extension. That was what I was saying. The reason for this is simple. .NET MAUI already provides a more generalized extension that allows you to reference any static value in your code, called static extension, or static for short. The following code shows the extension class basic outline. To use this class in your XAML code, provide the name of the static variable you want to reference in the member property and the provide value in the member property. Xstatic member. And the provide value method returns the value in this variable. Huh. .NET MAUI provides a set of other markup extension classes which you can use for a scenario such as data binding. Now we're talking. Now we're talking. We'll get into data binding, referencing dynamic resources and styles, and handling arrays of data. So when you're doing more, you're pulling data from a database and it's going to dynamically show something on the page, we're going to get into this kind of syntax, which makes sense that they introduce this here, applying the markup extension. Okay. This is an important sentence. .NET MAUI provides a set of other markup extension classes which you can use for scenarios such as data binding. The binding markup extension. I've done a little bit of this. Here's an example of how you can use the binding markup extension in XAML. I've done a little bit of this. My view model. Here's the binding welcome message. So the label is binding to the welcome message. The welcome message property is here. And it's set to hello from MAUI data binding. Yeah, I've done a little bit of this with view models. So this seems to be common, which is why they introduce extension classes here. Even though I didn't love this scenario, I do love this scenario, such as data binding. Which markup extension allows you to set XAML property to a static value that's defined in a code behind class? This is static extension. I believe. Which interface do you use? iMarkup extension, iMarkup extension, iMarkup extension. Which markup extension allows you to set XAML property to a static value that's defined platform specific values in XAML? I wonder if people actually read this, because I'm not a slow reader and it says 5 minutes and it's who's reading this in 5 minutes? I mean, maybe I just read it at maybe I do read at a slow pace because I'm trying to internalize it and trying to actually grasp it. But who reads this in 5 minutes? You're not really reading it if you're reading it in 5 minutes. All right, rant off. Your app's visual experience will be different on each platform. You often need to fine-tune your UI based on the visual elements. .NET MAUI enables you to manage your app's layout based on device properties. In this unit, you'll learn about features that allows you to tweak your UI for your apps according to the platform on which they're running. The device info class that provides specific information for the device on which your app is running. Through properties, the most important property is the platform: Android, iOS, WinUI, Windows, and of course Mac. Consider the following scenario. A .NET MAUI iOS app default behavior is that content added to the page encroaches on the iOS status bar on the top of the screen. You want to change that. The simplest solution is to shift the content down. The note solution you created in the previous exercise addresses this problem by setting the padding down 60 points. If I'm thinking padding top, right, bottom, left, but that must not be the order. The content down from the top is the second one, so maybe I'm just thinking padding in HTML. It's top, right, bottom, left, but it must be a different order. The issue is that the problem is only applicable in iOS. Shifting the content down on Android is a waste of real estate. Why don't you look at the platform property to solve the display problem? You can add the following code to your constructor to expand the padding for only iOS. So is the platform equal to iOS? If it is, here's your thickness. Otherwise, here's your thickness. That's cool. This code works, but it's in the code behind. The padding in the user interface specific value. Arguably, it's more appropriate and convenient to do it from XAML instead of the code behind, using the on-platform markup extension. Again, with the markup extensions. Markup extensions. This one is the binding markup extension. .NET MAUI XAML provides the on-platform markup extension to detect the runtime platform within your XAML. I mean, it makes sense, markup extension, right? So you got some certain amount of tags in your markup, and markup extensions add to that. So here, this binding markup extension is brought in. Maybe here, binding context. The binding markup extension. And this is the on-platform markup extension. The on-platform markup extension is generic. It takes a type parameter. The type arguments attribute specifies, ensures the correct extension type is used. So since it's an extension, I'm assuming We have to do something to bring this extension in to the XAML. And value is color, type arguments, value silver, green, yellow, background color. So here's the vertical stack padding on platform, vertical stack background color on platform. The syntax is a little verbose, and there's a reduced syntax. That's cool. Which markup extension can you use your XAML code to detect the platform on platform? What is the purpose of the type arguments attribute? Specifies ensures the correct extension type is used. All right, at least the teacher's getting some green check marks. That's good. Add behavior to your XAML. You previously modified the Notes app to move the UI layout from C# to XAML. Yep, you're now ready to add the following features. Support customizing the label's font color and background colors and editor controls. Support customizing the label's colors and backgrounds and buttons and editor controls. In this way, it's easy to adjust the app to make it more accessible. Adjust the editor's controls height on Android and iOS. While running on Windows, the control has sufficient width. On an Android phone and an iPhone, you're working with more vertical space. Using a static resource in XAML. You'll create a static class to hold the app's font color and background color values. You'll then use static markup extension to read these values from the class and apply them to the XAML. Note, a working copy of the app is available in exercise 2. Okay. Close. So I cloned this repo. Close it down. And exercise 2, code of conduct. Add a class, a new item. The class template is selected. Name the new class shared resources, then click add. Okay, mark the class as static. Add a read-only field. This field currently provides a value that corresponds to blue, but you can modify it using any other color. I think the idea here is just to get used to using these. Add a second static field named background color. So we got font color, we got background color. Open the main page. main page XAML. So above the class, XML namespace? No, I'm not sure. Above the class. So this adds this notes namespace, which this static class is in. So this static class is in the notes namespace. This adds the notes namespace to our schema, if you will. So it's recognized. XML namespace :notes. And then pointing it at the C# namespace, CLR namespace notes. Okay, that makes sense. Add the text color to the label. It uses static markup extension to retrieve the values in the static fields. Static member notes, shared resources class font color member. Label for the notes, label text of notes. And again, I did this with the, so this is member notes. So this is the notes namespace, shared resource class font color member. And I do see this being useful with that data binding. Use the X static markup extension to set the text color and background color for the editor and button controls. So the text color after the height request. We got a text color here, text color here. Text color and background color. Did I forget a quote? I sure did. So we got two more buttons, and this has a text color and a background color. And this has a text color and a background color. Rebuild the app. See if we can get this bad boy running on Windows. As it's doing a build. I need more RAM. There we go. Build succeeded. Just launch this in my Android emulator, since launching in Windows seems to be giving me a problem more than anything else. When I reboot my emulator, it does this, it kind of black screen, and click it, might take a second, click the power button, wake it up. Now it's waking up. Return to Visual Studio when you're done. Open the main page, locate the definition for the editor control, modify the height request property. This markup sets the default control to 100 units, but increases it to 500 on Android. Called extensions, but it seems like it's just built right in. And that was on the editor control. While it's still doing its thing. Unit summary. The coded UI makes it difficult to manage layout and behavior. This approach often includes layout and behavioral logic, and it results in a tight coupling between the two. A change in the UI design can knock on effect to the rest of the code base. Maintaining a code base where there's no clean separation can be difficult. .NET MAUI allows you to define a UI using XAML. The separation lets you focus on behavior logic in your C# code files. The UI designers can now focus on the UI while programmers can focus on code. .NET MAUI XAML allows you to customize the UI for each platform using on-platform extensions. Lets you design apps that can use OS-specific UI features but still look good on all platforms. And we hit these objectives. Let's click complete. Keep up the great work. Awesome. Well, if you kind of followed along, I hope you... Oh, it loaded my text from last time. And I paste in what I had on my clipboard. Couple takeaways for me. The extension, the markup extensions, because this X static, I've seen this before for binding, so it makes a little bit more sense now. You know, with things like this on line 4, where we're using view models to kind of bind our UI with a data source. So that just makes that make a little bit more sense. So my phone's going nuts. and also learning that constant variables in C# are static. It's another takeaway. Thanks for hanging out, guys. Have a good rest of your day. Hopefully you learned a thing or two. Take care. Bye.